Okay, thanks for joining today's seminar. I will talk about the vision language model today, how they deal with high resolution image. Okay, so we have the big problem is that if you research about vision language model, you will find that almost vision language model depends heavily on the pre-trained vision encoders, like the clip. Uh, but the clip encoder is trained on image size is really low, which is around 200. So this will, you know, downside the detail of the image, and even the best current vision language model, which is GPT-4, suffers from this curse. Uh, there are two ineffective approach. The first one is like you have a high resolution image and you downsample it to low resolution, uh, but it will blur the detail. And the second approach is you still keep the high resolution image at the same, and you divide the image uh, in equal patch, but and consider each patch as the token, but that obviously will cause computation cost, and that's why the paper comes to play. Like it can uh, the vision language, the vision ability of this model uh, is kind of, they say that they strong than the GPT-4V, which is considered the best uh, for now. So there is one example of the paper is that where to buy a mug like this based on its logo, like uh, like by like we as a human, it's hard to define which which logo the mug uh, belongs to, right? And even the GPT-4V answer wrong, but the seal, which is the method from the paper, can can answer that correctly. So this is the contents I'm gonna walk you through today. The first is problem I just mentioned before. The second is fundamental of vision language model. Okay. Uh, Understanding vision language model is prerequisite to understand this seminar. So I will uh, summary uh, that knowledge. The highest level of vision language model contains three main modules. The first is vision encoder to encode the image, extract the most useful information. The second one is LLM decoder to generate the text, and the third one is projection layers, uh, which will receive the information of the vision encoder and translate it to the LLM, because the output of vision encoder has the different distribution with input of large language model. So we have some way to correct the distribution, and the projection layers acts as a translator for LLM. Okay. Um, okay, this is the the algorithm, the framework that the paper proposed, which is search and tell. The basic idea Okay, this is the overall workflow. The left part is the main flow of almost vision language model, which is we have vision encoder and language model, and the right part is the most uh, the most contribution of the paper. Okay, uh, remember that the paper is try to solve the problem of dealing with high resolution image. So this is the main flow, is that we just text the input as normal, and the large language model will evaluate if the information taken from the encoder is enough for answering the question, and if not, it will list all needed but missing information in the format of a list of target objects. uh, okay, and then it will initialize a visual working memory. This is also this is also a new concept proposed by the paper, and the virtual working memory, you can understand that as a dictionary. So there is four block. The question block will contain the initial question. The global image will be the original image. The search target and the target location uh, will be will like at first, at the beginning, it will empty, but after the right part, the search part, it will be filled with the target object. For more detail, I will for more detail this is the pseudocode of the whole paper. Okay. um, okay, the input of the function is I stands for image, the T stands for text, which is the question, and the phi will be the threshold. First, we will pass the image and the text question to the VQA LLM, which is the part here, and the LLM will try to answer directly, but if it cannot, it will list all the needed target objects. For more detail, I have one example right here. So if the question of us is what is the color of the hat of the woman standing next to the tree, so the LLM will the list of target objects will be hat, woman, and tree, which is three main objects to answer the question. Okay. And then they will initialize the virtual working memory. The virtual working memory will add the image and the question, and okay, so they will look through the list of target object, and they create a queue, and they add the image and the priority score. But in the beginning we do not have priority score, so we just add the infinity plus infinity along with the original image, and we pass the Q. The S here is target object, and the V, the threshold, to the visual search. I will explain the visual search detail later, but for now you can understand that the output of the visual search will return for us is none, or is either none or or the coordinates the of the target object. For example, we are consider the target object, which is hat, and then the search result will be the coordinate of the hat in the original image. And and the virtual working memory will add the target object, and yeah, yeah, which is the input of the VQA LLM again. So the virtual working memory finally will look like this. We have the image here, gonna be the token of the image. Target object name, object here will be the embedding location, and the question. All of this will all of this will contribute to our final question. Sorry, final response. Um, I hope that you understand the main idea until now. And is there any question?
So I have a questions. So an image go through an image encoder somewhere in this pseudocode, right? They will encode the image and they will define the location of the target if it exists in the image, then pass into response. It's
Yes,
like the main
the
idea.
you can see there is the module name VQA LLM here. The VQA LLM refers to the blue block here. Is that it takes the image, and T here refers to the question. Yeah, and
The, okay, the blue block is the whole everything. Like
is
the
the
is a
VQA LLM.
vision.
And actually,
Uh,
if you see the line number 8, there is another function called visual search. And the visual search function will, like the search, like they will search if the object exists in the image. If the object exists in the image, they will return the coordinate. And I will explain it later. But you understand the
okay,
main
okay.
idea, right? Okay.
Yeah, right.
I have
And
a question.
okay.
So, um, in a way or another, the vision encoder is still going to be used. So, how is it supposed to help increasing the effectiveness when using in high resolution image?
Okay.
Like the vision encoder, what's it gonna what the model is gonna be used in the vision encoder?
Mm, I am understanding that your question is how this flow improve when dealing with high resolution image, right?
Yeah.
Okay. You can see that if we have a really high resolution image, and this is our question. Sorry, I will take that image to illustrate. So, based on the question, it the algorithm will search for the objects needed to answer the question. Like we need to define where to buy a mug based on the logo, right? So we need to find the location of a mug, and then define the logo of a mug. So that's why I provide this example. It will break down the object in the question, and then recursively search for the object, And
It sounds a little bit like chain of thought, isn't it?
mm, no, it's not chain of thought. Okay, if you still not clear about this, maybe after the next part you will understand uh, clear. Okay. Okay, so this is the main flow. As I said earlier, we have another function called visual search, where we define if the objects in the image, in the original image, right? So this is the search algorithm. Uh, okay, it will return cropped image and coordinate if that object exists. The main idea is is like it is a recursive algorithm. Okay. Okay, so here is the example. We have a really large sized image, and we need to find if the backpack inside the image. So okay, remember that we here is a queue, and we got the current image. Current image is original image, by the way. And we have another function called visual search model, and I will explain it later again, but you understand that it is it will it is just a vision language model, and in that case the ULAVA model. So the instruction is please locate the backpack in the image, and that 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 vision language model will return two things, which is target coordinates and confidence of that bounding box and the heat map. So you might ask that the normal vision language model just return text the the text uh, and and yeah, and this paper proposed a way, some module to return things other than text. Okay, so if the target confidence is high, then we directly return the target coordinates, which is the coordinate of backpack. But in that case, we assume that we are in the worst case, so we go through the entire algorithm. And if the heat map, the max value of the heat map is smaller than the threshold, then we will use the vision language model again. But uh, in that case, we use vision language model to generate the contextual queue, like what is the most likely location of the backpack in the image, and it will generate for us the uh, kind of the recommendation, the suggestions, and the contextual queue can be like the backpack is most likely appear on the back of a person, and that makes sense, right? And we use the VLM model again, but the instruction will be different. Like please locate the contextual queue in the image, and it returns for it two things. Underscore here refers to the target coordinates, but in this line we do not care about it. We just care about the heat map. Okay, so once we have the heat map, we divide the image into sub image, equally divide, and then we calculate the priority for each sub image based on the heat map, like based on the heat map, and when we add the sub image based on the priority score to the queue. So in that case, you can see that the left most below part will be priority most, right? So this is the first image in the queue, which is a quarter of original image, and then we recursively apply the function again to search a backpack on that cropped image. Okay, and if the target confidence is high, then it returns for us the target coordinate, which is yeah, the backpack. Okay. Uh, okay. Are there any question until then?
So the whole process is input is an image. They split image into multiple part, like many part, and they go through encoder, then go to LLM. So LLM can know which part from the multiple part contain anything, right?
Uh,
So they the location and the object in the image. So when user like provide a text to ask about anything, they will search in each part from multiple part to find the most priority, like that.
uh, please notice that the visual search model here is different with the with the blue part. Is like a different model. It's like different vision language model. We ask them to locate the backpack in the image.
Okay, okay. So how different to the first one?
What is different?
The visual search model and the first one, how they are different? Like they
Okay.
can do, yeah.
um, you ask about how visual search model differs with the blue block here, right?
Yes, yes.
Okay. uh, okay, you can here you can see the image from the lava model. The visual search model will be exactly the the normal vision language model. In that case, they use lava. And how they difference is that this blue block here is the proposed is the architecture that is proposed by the author. That is a new architecture.
Oh, okay, okay.
Okay.
But in the algorithm, the pseudocode that you show me, do they combine or something?
Yes. Uh,
Mm,
you can see the main flow here. This is the entire contribution of the paper. The main function is COVQA, and the blue block here is the VQA LLM, which is uh, main block to generate the final block that generate the answer for us. And the lava model you see in the pseudocode here is from line number 8. It belongs to visual search. It only be used to search if there is object in the image.
okay. So can they use the first module to do the task of the second one?
uh, like you asked about what if we use the same
Because,
model, right?
yeah, yeah. Is it
mm, you,
possible?
you can see that the blue block here, you can see that the fire icon is that they has not been changed, has not
Okay,
been fine
okay.
tuned actually. Okay. And the reason why they do not use the lava model to replace the blue block is that as I said at the beginning, there is a problem is that uh, the current vision encoder of almost vision language model is trained on input image with the very low size, right? And they try to fix that by changing the vision language model with the high resolution image. That's why they need to train again. Okay. uh, okay, once we get the search result, which is the coordinates of the backpack, uh, and then we add it to the virtual working memory, because virtual working memory has four blocks. The first one is question and global image, and the two remains is search target, which is the cropped image, and in that case it is just the backpack, uh, and the final one is target location, which is coordinate. And once we have enough uh, information in the virtual working memory, we pass the virtual working memory as the input to the VQA LLM again to generate a response. Okay. Okay. So as I mentioned before, the normal lava model will directly generate the text, the raw text for us. So they perform some uh, they add two new modules to get the target coordinates and confidence and the heat map. Okay, so the lava model will if you read about lava model, you will know that inside its vocabulary there is a token. LOC stand for localization or location, I don't know. But after but the lava will the output of lava will contain the embedding of that token, and we use that embedding and then pass that embedding into two different multi-layer perceptron to get the VTL and VCL. VTL mean that I don't know, but the TL maybe will be the target location, and CL stands for Q location. Q search in search Q map. Okay, but understanding high level, just for understanding high level, these two modules is added to generate the target coordinates and the heat map. Okay, and these two multi-perception layer is trained. You can see the fire icon at the right part of the architecture. Okay, that's pretty much of the algorithm. Are there any questions? I think the most understand. I think the hardest understand part is this one.
Okay, I have a question. So, in short, uh, it would be the heart of this paper is the search, the guided visual search. That's right.
Yes,
By by dividing the image into smaller and smaller part to get the
exactly.
to get the to get the object,
Okay.
and the VQA is just for question and answering. Is that right?
VQA, the blue part.
Yeah, that one. Is it just for chatting, like for sport parsing the in user prompt and printing out the generated content based on the search model?
Yes, you can see that the virtual working memory contains four blocks. You can see the four blocks: question, global image, search target, and target location here. And it will be the input for the vision encoder perform some resampler and linear language model which adjust the layer attention layer to generate the raw text, the response, the answers, and the after we search, like the whole things here is just for search for target object in the original image, and once we know that the object is in the original image, that will be the input for the VQA LLM. That's a normal VQA LLM, but it's fine tuned.
How exactly does the resampler and the linear part work?
Sorry,
How can it
okay.
combine the global image with the search target?
Okay. Actually, I did not read this part because I understand that the overall idea, the general idea, is this VQALM is just like other large language model with some modification, and that modification is not the main part of the paper. So they maybe they state it somewhere, but I'm surely that uh, the resampler and the linear function is not the main part. So I did not read about it. But you can think that it's like a projection layer, like I said before, to translate the vision encoder to the large language model right here. The vision encoder and then the projection layer and then the large language model, exactly the same here. So I do not read about this.
Yeah, but like the global image, the box of global image and the box of search target. So here it's, is it images that that are sent to the vision encoder
Yes,
on?
yes.
Okay.
So if you wonder what is the input of VQALM look like, uh, then uh, maybe your question, uh, your answer for the question for your question is like in this slide.
What about the training phase of this model?
Yeah.
Like what data? is it trained on, and how what which parts are getting trained?
The okay okay, but first you should understand that the VQALM here is exactly uh, the overall the general architecture of large language model, which consists of the vision encoder, the projection layer, and the large language and the decoder language model. So the training process of this framework is exactly like the same. And and for the question, which part is trained? Uh, which part is trained? You can see that. Yeah, only the language model, the vision, the projection layer is trained, and also the multi-layer perceptron is trained. Actually, is fine-tuned, which is more correctly the LLM here is this part is this blue part, but is trained with LoRa, fine-tuned with LoRa. Okay. Okay. I think we can play with uh, some demo. Mm, okay. Mm, wait me for a minute. Okay. So this is their project page. They explain quite high level. So if you want to understand low level, you need to come come and you need to read the paper. Okay. Uh, here. So given that image, they will search for the word. Uh, okay, and it is hard to for the VQALM to generate the image directly, so they need the help of a contextual cue, and then they crop image, right? They crop image based on the heat map summation or the pixel of subpart, and that is priority score. And once we
Okay ạ.
okay, and once we crop the image, we if the cropped image at the first time does not clear enough for the for the lava model to generate the to decide whether the object is in image or not, they will crop again, and then yeah, they and then cropped until the target spotted. So that's how that is the approach of you know dealing with the high resolution image to understand deeply about even a small object.
Does this model support Vietnamese?
Sorry, can you ask again?
Does this model support Vietnamese?
I don't think so. This is really, small open source. Uh, this is small open source and have just accepted at CVPR. So I think that they have not uh, developed the project to the extent that supporting Vietnamese language.
Is this model from 2023?
Yes. Yes.
Okay.
Here. Uh, okay. And if you want to talk about the uh, the usage of this model, like we wanna use some part of this model, we will use the vision encoder right here, because the vision encoder now can sorry we if you wanna utilize the the backbone of the paper, you have to utilize the the search, the yellow part also. Okay.
So this model would work best with uh, question and answering context.
mm, okay, let's see the result. I did not delve deep into which tasks the model uh, can do. Yeah, but all the examples they show us is just visual question answering, so I assume that that is the task that this model support. But in general, but in general, yeah, that's the task that I support. You can understand that. And in case you uh, have not known yet, the GPT-4 model is the best model until now for all tasks. We have so many tasks: the image reasoning, image captioning, vision question answering, the math related, and so on. But the CO this paper framework, this paper proposed a framework uh, that even stronger than the best model at the VQA tasks, only on the high resolution image, I guess. Okay, so is there any question?
Can you give me some name of VQA datasets? High resolution VQA datasets?
Okay. Okay. Actually, the result, the data sets, I did not read yet. Mm, actually wondering about how they get the high resolution image data set. It's okay, really also a amazing part, and that's my mistakes when not covering it in this seminar. Hmm. Okay, but you can check it yourself later. Maybe they use some existing data sets or create their own. I don't know.
How many parameter in this model?
Parameter.
Yes.
Hmm. Like really good question, and my mistakes were not uh, reading about this. Okay, so the Lava model they use uh, 7 billion version of Lava model, but they contain two vision language model, right? Uh, okay, okay, I cannot answer to you simultaneously.
7 billion, I think, in the
S-
evaluation section of the paper.
mm, I don't think so because they overall architecture they contain two model, right? The vision backbone and the blue part. The vision backbone they use is 7 billion version of Lava model. So the 7 billion should be the least parameter.
Uh, when change a model in a high resolution image and it can answer really hard questions, we just focus on a small part of the image. It means the model like have the reasoning ability. Can you think it can apply for some reasoning task related to geometry or something else?
Okay, you know the abilities of searching for the very small objects shows that the model understand the image really, deeply. So I think the backbone, the the embedding of the vision encoder or even the large language model will be also amazing at the related tasks.
Okay, but it trains on reasoning tasks like it need some it needs some information to figure out something else. Like give it some example, then it can based on this analyze the example, then um, provide the answer for the single task by philosophy, philosophy.
Okay, so for the first question, this model is only trained with the VQA tasks, like its name suggests. And for the second question, is that the backbone can be used for zero shot learning tasks, isn't it? You asked about it.
Can this backbone can use for future learning, future prompting? Like
In
it
in another
receives
task.
some, yes, like now the now the model either receive one image and one questions and answer, right?
Mm.
Can I use some uh, like my input can have three images and three questions and also three answers. Like example, few short example, then ask them for the questions to make questions. Do you understand?
So you refer to the warm up process.
No, no, no. When infer can we give it some when we prompt to the model to infer it? Like I have a um, really different task, but I want to um, exploit the ability of image understanding of this model. Can I give it some example like pair of questions, image, and also answer as the example input as a prompt, and then ask them for new image and new questions.
Yes. I think not. I think I'm quite confident that this model can perform uh, different tasks uh, with even zero shot uh, learning, uh, because you can see that we just change the way we prompt the model, like how the logo of the mug relate to the kind of the screen of the PC, right? So the objects that we want to search will increase, but that doesn't matter because the model will also understand all of them. But there is some drawbacks is that the data set of that model is fine-tuned on it's just the VQA dataset. So to boost the performance of that model, we the simplest the simplest way is to fine-tune this model on more dataset with different tasks.
Mm, okay, the ability to understanding the image of this model, do you think um, is either anything special and when I input this model a normal image with a normal resolution like 200 or 300, do you think it still work well?
Yes, of course. If you look at the pseudo code, uh, there is a line. Hmm, here, there is a line that sorry, this pseudo code. Okay, there is a line number 4. If the target confidence is high, then
Okay,
it
so sorry to sharing the screen about the website, not the Facebook code.
okay. Okay. If you guys do not have any other questions, so this minute I will end here. Thank you for listening.